All right, here we go. We're going to pick up the rest of Part P or Chapter P with P6 for 2 days, rational expressions. A lot of with the rational expression stuff. Today is going to be mainly simplifying, multiplying, and dividing. We'll get into the adding and subtracting tomorrow. For those of you that will be gone tomorrow, then you can just pick up the notes off of here tomorrow morning or tomorrow midday. Everything, and then we will test over the second half of Part P or Chapter P, not next Monday and Tuesday, but the following Monday and Tuesday. I don't have the dates right off the top of my head, but we're in this for about 2 weeks, and then test is split up over 2 days, and it will be on a Monday and a Tuesday. So just be aware that you will have a test on a Monday. So whenever we deal with a rational expression, all a rational expression is just a quotient of two polynomials. Okay, so whenever we were in Algebra 2, the domain of an expression is the set of all positive input x values. Okay, so in this course, it'll be important to consider everything that we do. If you have anything in the denominator, you always want to check the beginning and the end. Okay, so in the beginning, there are certain values that x cannot be. That's whenever we will set restrictions on your domain. Usually we'll just say that x cannot be equal to, and then various values. So like on the bottom side here where we have the 4 over x minus 2. This is a rational expression. You have a polynomial on top, albeit just a constant 4, and then on the bottom side you have x minus 2. So the big thing here is whenever we do the restrictions, it's what can x not be. Remember, you cannot divide by a 0. So if we can't divide by a 0, then down here in the bottom, x could not be equal to a positive 2. Because if it was equal to a positive 2, then you would have issues. You can't divide by the negative, or divide by the 0 rather. Each one, just like before we start down here, you would have to see what can x not be and go from there. So just like we've said before, because it's a division problem, we can't divide by 0, and it's undefined if you do that, or it's no solution, or you get an error. Okay, you cannot have 0 be in the denominator spot. So like on 1, where it's 7 over x plus 5, what can x not be? What is x? If x is a certain value, what is going to make it 0 on the bottom side? Negative 5. So all we would put, as far as whenever we would finish solving, we would just say x cannot be equal to negative 5. Same way down with 2. You have x over x squared minus 36. You can either do one of two things. You can set x squared minus 36 equal to 0 and add 36 and do it this way and say, well, it can't be, well, square root of 36, so it can't be a positive or a negative 6. Okay, so those are the two values that it cannot be. Now, what we'll do most of the time, to be perfectly honest with you, is we're going to factor, okay, because a lot of these are going to cancel anyway. X squared minus 36 can factor out to x minus 6 and x plus 6. So you just set each one equal to 0. We're still going to get that x cannot be equal to plus or minus 6. And if you want to put negative 6 and positive 6, that means the same thing. Then like on number 3, the reason why we go ahead and factor it is it's a lot easier because you can't set x squared minus 5x minus 14 equal to 0 without factoring. So the bottom side here, two numbers that multiply together to give me a negative 14, and then combine to give me a negative 5. So x minus 7 and x plus 2. So once it factors, remember, it's just the opposite of the back divided by the front of each part. So x cannot be equal to a positive or negative 2 and a positive 7. So realistically, with simplifying rational expressions, multiplying rational expressions, and dividing rational expressions, they're all three very similar. And they're very similar in the fact that what you're going to do is essentially you're either just going to cancel things. If you have anything that matches on the top versus anything on the bottom, then they just cancel, and we just put them on the chopping block and we just take care of them there. So simple thing, factor whenever you can, because whatever you do, if you multiply straight across or you divide, divide's the only one that's going to kind of have the extra little step in there. We'll get to that in a second. But simplifying and multiplying are really the same thing. Okay? Whenever you simplify, you only have one rational expression. Whenever you multiply, you're going to have multiple. Okay? You always want to check to see what can x not be at the beginning and the end. Okay, so from that original, so if I have x to the third plus 3x squared all over x plus 3, all I want to do, can I factor, first off, can I factor the top? What can I factor out of the top? X squared. What am I left with? X plus 3, and then I have x plus 3. Now, before I start chopping things off and I start getting rid of things, okay, and simplifying, what can x not be before we even get started? X cannot be negative 3. Okay, so I know that going in. Now, I may add to this list. I will never take away from this list. Okay, so if it starts as a value that it cannot be, then I will never remove a value from that restriction. I can always add numbers to it. I can never take numbers away from the restriction. So then it should be fairly simple. What's going to happen on top? What is there something that matches on top and on bottom? Yes? X plus 3. So the only thing I'm left with then is x squared with my restriction that x cannot be negative 3. Now, the reason why on like number 5, the reason why I kind of wait, I factor everything out first before I state what my restrictions are going to be, and I definitely want to do it before I start canceling or simplifying. So on the bottom, I'm going to worry about the bottom first. Two numbers that multiply together to give me a positive 1 that combine to give me a positive 2. So what's the bottom side going to factor out to? X plus 1 and x plus 1 again. What about the top side? X minus 1 and x plus 1. Now, what are my restrictions? What can x not be? Negative 1. Can it be a positive 1? Is that okay? Is that a restriction? Once we get to the point where everything's factored, then we're just going to start canceling. I have an x plus 1 and I have an x plus 1. I can only take 1 for 1. I can't take 1, since there's 1 on top and 2 on the bottom, I can't get rid of the 2 on the bottom. Okay, it's only 1 for 1 here. So then, only thing left, x minus 1 on top, x plus 1 on the bottom, and my restriction is going to be that x cannot be equal to negative 1. Now, when we multiply, again, it's very similar to what we do whenever we simplify. The only thing different here is we're going to have more than one rational expression. Okay? You're still going to factor out numerators and denominators completely. You're still going to look at the denominator of all the factored parts on the bottom side, and then divide out common factors between both fractions. Basically, then it's just like you're going to simplify. It's just I have more terms is really all that's going to happen. So, like on 7, if I have x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. So again, the first thing I want to do before anything, before I start canceling things, is I want to factor. Can the top left up here with the x minus 7, can I factor anything out of x minus 7? Yes, no, maybe. No. What about with the x minus 1? Can anything factor out of it? No. What about the x squared minus 1? How can that factor? X minus 1 and x plus 1. Then what about the bottom side where it's 3x minus 21? What can I factor out? See you, Sam. So the bottom side then we can factor out a 3 and have x minus 7. So before I do anything, here's where I want to get in with my restrictions. What are the values just with the bottom side here that x cannot be? Positive 1 and a positive 7. So once I found my restrictions, now I can just start canceling or simplifying, whatever word you want to use. What's going to cancel? What do I have on the top and what do I have on the bottom? X minus 7 and an x minus 1. All I'm going to do from there is just write what I have left. So, top side, I have x plus 1. Bottom side, I have 3. X cannot be a positive 1 and a positive 7. Now, the only thing with division is whenever you divide, you're just going to go keep, change, flip. Okay, then proceed with the process of multiplying. The only thing that you want to do first is you want to check to see what can x not be before you do keep, change, flip. So, if I still want to factor it. What does the top side factor to? Two numbers that multiply together to give me a negative 8 and combine to give me a negative 2. X minus 4 and x plus 2. Then the bottom side down here with x squared minus 9 is going to be x minus 3 and x plus 3. Now, I'm going to go ahead and kind of do two things at once. I'm going to look here and I'm going to look here. What are my restrictions before I get started? What can x not be? Plus or minus 3, right? Now, I'm going to, just because I want to shorten this up a little bit, I'm going to do, I kept it, I factored it, I kept it, I'm going to change the sign, and then I'm going to flip the fraction. So that means that x plus 3 is going to be on the top, and x minus 4 is going to be on the bottom. From here, all it is a multiplication problem. What can I simplify, or what can I reduce or get rid of that I have on the top and I have on the bottom? x minus 4, x minus 4, x plus 3, x plus 3. So from there, my final answer is just going to be whatever's left. So x plus 2 over x minus 3. My restrictions do not change. X can still not be a plus or a minus 3. There will be some times that you will have values, like if that x minus 4 didn't cancel, then we would have to tack on a negative 4. Okay? That is sometimes going to be possible. Okay? There may be values that will be there that wouldn't be there before. You want to do one like 10, or are you good? Good? All right. Your assignment is posted. I know it's on Pearson. I'll put the book part, if I didn't already, I did not already. I'll put that on Canvas if you just want to do it in paper. Remember, if you did not get the 85 or higher, then if you didn't do it online, if you need to do it online still, do that. It should be open for you. There's the assignment.
Was that you have it already seen?
Okay. Thanks.